just look at that. That's some maths, that is. That's the sort of thing that if you show to a non-mathematician, they're like, yeah, that's some serious maths, that is. What the hell is it? But because you're mathematicians, I think you'll be able to unpick it, to figure it out. And that's what I want you to do first. I want you to grab pen and paper and just see what you can do with that. Maybe you want to separate it into numerator and denominator there. But pause the video, see what you can write down. Do that now. Alright, I'm going to do the same. Let's look at these two things individually. What does this mean? Well, this form of a complex number, we have the modulus of it out the front and the argument in there, the angle. So hopefully, one of the first things you did was a little sketch of it. We've got it at an angle of pi by 12, that's maybe about here, and a distance of 2 from 0. So that is there. Maybe let's call this first one A. So that is A there. And then down here, we've got distance of root 2, that's slightly less than 2, and 5 pi by 6. Well, pi radians would be all the way over here, so it's somewhere over here. So let's put it over there. Root 2 and... ooh, that one there is pi by 6, and that one round there is 5 pi by 6. There we go. I really hope you did a sketch first. Sketch, 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 sketch. Always sketch them. Okay, after a sketch, what else can we write down about these two complex numbers? You should know how to write complex numbers in a few different forms now. We've got this form here, where we get explicitly the modulus and argument. The first form we learnt about didn't have causes or sines in. So I think the first thing I want to do is write it out like x plus iy. What can we do with that? 2 cos of pi by 12 in my class whiz, making sure I'm in radians, gives... well, that's gross. Let's swap to blue. We've got root 6 plus root 2 over 2. What if we change that cos for a sine? Root 6 minus root 2 over 2. That's actually quite nice that turns out like that. Plus root 6 minus root 2 over 2 times I. Those two are the same. Let's do the same down here. Root 2 times cos of 5 pi by 6 gives, that's a little bit nicer, minus root 6 over 2. I bet sine's going to be quite similar. Root 2 over 2. Alright, was that right? Yeah, wow. Plus root 2 over 2 I. Okay, maybe you've written that down. There's another form that I'm thinking of. The one that we learned most recently, and that is the re to the I theta form. The one that comes from Euler's relation. And that's going to be very easy to write down because we've already got the modulus and argument. So we write it as re to the I theta and re to the I theta. Oh, I've just noticed I've missed out that there. That should be a 12. Okay, hopefully you had something like that written down. Can't fit my whole page on at once. Something like that written down. Maybe you had more written down, and well done if you did. But I think that's as far as I want to go. You need to be comfortable with moving between all of these 3 different forms, because in different contexts, these can be useful. Like in some contexts, this one's more useful than this, and vice versa. In the context of dividing these 2 complex numbers, which one do you reckon is more useful? If you haven't already had a go at actually dividing these complex numbers and getting an answer, I'd like you to do that now, so pause the video again and have a think about which of these three forms is going to be the most useful, the easiest way of doing that. Do that now, pause the video. Okay, what I've been doing while you've been on pause is just copying out these two forms from the page over there. Now looking at it, one of them immediately looks easier. This one. No jokes, obviously this one. Because for this one, what we'd have to do would be to rationalise the denominator, so multiply top and bottom by the conjugate of the bottom, and then simplify it all up and we get the answer. I can't be bothered doing that. This is really easy. Let's do it. So we can treat the powers just as we would at GCSE. We've got 2 divided by root 2 is root 2, and when we divide powers we subtract them, so we need to do pi by 12 minus 5 pi by 6. I'm just going to do a 12th minus 5/6 on my class whiz, negative 3/4 minus 3/4 pi I, like that. Great. Now, an exam would tell you what form to write the final answer in. Sometimes they tell you to write it exactly like this. This is a perfectly valid way of writing a complex number. Or we could quite easily convert it back into this and then plug it into our calculators, the cos and the sine, in order to write it in the x plus iy form again. But for now, I'm just going to leave it like this. So in this case, this form was definitely the easiest. But that's not to say that it's always going to be the most useful form. In some contexts, especially when we're using an Argand diagram, so we need to know some coordinates, this form might be more useful. What's really important is that you are comfortable moving between all three of them. So that's up to you to do some practice now.